Okay, graphic text. Lesson 18, part 1. We'll have at least 2 parts to this. Printing some text on a graphic screen makes it sound kind of boring or easy, but we'll see what we can do. See how we can do some things with the hprint command in BASIC. We'll talk about BASIC, the good and the bad about hprint. We'll also look at a lot of things in the assembler side, the things that you can automate and really do with text. Got a lot of new code that you'll be able to experience, and we'll see what all we can do. So we got a lot of things to do. Here's some of the things that will show you what can be done. We'll go back to some history of text in ASCII and what does ASCII really mean, and what are all the characters and all the control characters throughout the ages. And after that, we'll just look at a lot of the code that I put together that we'll share with you when we get done with this. So on with what we're going to do. Get my other screen up here. Okay, here's something we can do. This is all done with graphic characters. Everything on this screen is done with some form of graphic text. Okay, we're doing characters, and we'll get into each one of these and what we can do and what you can do with them. Here's some more stuff. We'll be able to have rotation with letters, 0, 90, 180, 270 degrees. You can print them stuff upside down. Some of our graphic characters will look like some dice you can roll. But before we get into all that type of stuff, we're going to take some history and go back and look at how we got here as computers and teletype machines and typewriters and everything else. Okay, the ASCII table, American Standard Code for Information Exchange. Excuse me. All right, this is you can find all sorts of these on the internet. I got this one many years ago, and this is the one I have used forever. It's kind of the official one. And what we're going to look at right now is starting here at hex 20 through hex 7. Later on, we'll look at all these control characters, which is over here, 0 through 1F. We'll look at them later on. But right now, let's look at what you print. And this also is when you're just printing on the screen on the color computer or teletype machines or anything else. If you want a capital A, okay, that's a hex 41. If you want a lowercase a, that's a hex 61. Okay, so over here we got starting at 20 is a blank, and then we got excuse me, a bunch of special characters that you have on your keyboard. We got the 0 through 9, more special characters. A through Z, uppercase, some more special characters, lowercase, and some more special characters. One thing to note, if you have a capital A, which is a hex 41, and you add a blank to it, which is hex 20, you'll get a lowercase a. Okay, and if you've coded on Unix or a C program or that, you do a 2 upper, 2 lower, that's all it's done. You can take an A and add 20 to it, and you get the lowercase version of that. Okay, on a color computer 1, 2, and well, on the 32 character screen on color computer 3, this is the characters that is used there. Okay, and starting here with hex 20, I'm going to say 20 down through 5A. It's the same thing as the ASCII table that we looked at just before. Color computer, they kind of change things around. They move the lowercase here, which you really don't use, and they don't have, some of the special characters are different, so we're not going to talk that. That's not graphic characters, that's just things that are in the computer. Likewise, this here, if you're on color computer 3 and you do a width 40 or 80, this is the character sets there that they use. And again, 20, which is the space, all the way down through 7F, is almost exactly identical to the ASCII table I showed you before. There's a few differences in the special characters, but all in all, it's pretty much the same. The control characters 0 through 1F These are some characters they got on this table with the accented characters. You can't print any of this on a graphics on a screen on color computer. Anyway, do a little. Oops. Back up here. Do a little history. This can be kind of my history. Back in the late 60s, early 70s, when I first started assembly language coding on an IBM 360 mainframe. Well, it was really before that. I worked on a 1401, but in the 360 era, there was no internet, no PCs, no cell phones. There was no CRT in front of you as you worked on something. You usually worked with punch cards and paper. And when I started having stuff where you had a terminal that was like a teletype machine as opposed to a computer screen. Okay, and I work for like a finance company in the banking industry, and on the mainframe, the application was here, and I didn't work in the application, the credits and debits, and that I worked as a system programmer with the system software and the networking software. And the terminal in question here that we used, and that was nomenclature was an IBM 1980-9. The most popular IBM protocol and terminal was the 7441. This was a variation of that, okay? And it was basically a Selectric typewriter. And if you're familiar with a Selectric typewriter, when you struck a key, this ball went up and turned. You typed an A, it would turn into that and rotated until it got the A and punched it on the ribbon on your paper. So it was a typewriter. Okay, it had all the first time I ever heard the word font was with this here. On this, if you lifted up this little latch here, you could lift that ball off of there and stick another ball in there with a different font on it. Okay, all the characters were on there. It just turned around. It was a mechanical device, but it was unique at the time. Well, this 1980-9 used that typewriter that IBM. They modified it and put it in a case. It had communications in it. It was buffered, so you could, I don't remember what the buffer was back at the time. Memory was very expensive. It might have had 1,000K. I doubt if it had that much. And it had a modem with a 75 baud. And don't laugh, 75 baud was that's slow and the color computer standards and that. But it was a mechanical device. It didn't go very fast as it typed and went from one side of paper to the other side of paper. It was slow. 75 baud was about all it could keep up with. Let's see here. All right, let's jump around. Here's some control characters that and other teletype machines used back in the day. And this was put together many, many, many years ago. And there's a lot of things in here that not every terminal used, but it was, I guess, a consortium put it together, things that different terminals used. And the things some of them you've seen before. You've seen, a backspace character. How about a line feed? Is hex 0A, okay, or carriage return 0D. Here it shift out. I think it defaulted to uppercase. And when it got this character across communications line, shift out, it put it in lowercase, and then you want to go back to uppercase, you did it. It was a shift in character. Old fashioned, but that's it. Okay, oops. If I can get, I'm sitting on playing with the mouse, hitting the button. The other one to talk about is this synchronous idle. Okay, other things that you might have seen before is escape character, but these things not all these things print. They were just things, control characters that was used on all these mechanical devices. Okay, and we're going to. Why am we talking about this? Because if we can't print them on a screen, a screen doesn't need any of these. If we can't print them on a screen, why don't we use this to make some new special characters? This synchronous idle. Okay, I always just went by idle. Okay, again, this 1980-9 was a mechanical device, and everything had. In the industry where I worked in the finance one, you walked in and brought in your little booklet with you. If you're old enough, remember when you took out a loan, you got a little booklet. If you had a savings account, you got a little booklet. You went into your branch office or your bank, and you hand them your book. If you was paying your loan, you'd hand them your book and your $20, and they would do a transaction in there, and it put your book in the machine, and it would print one real short line that you would done. It might say, $20, $15 in principal and rest and interest or late charges, whatever it might be. Very short transactions. Everything was very short. Later on, we had we had 40,000 terminals out there, Canada, U.S., and Mexico, and thousands of branch offices. And they got to the point as the data processing got better, they wanted to get, well, what about some recap of what we did the day before? And there was transactions that said you took in $500 in cash and you handed out $250 in cash and you had checks and that. Very short little, you know, didn't take much transmission. Then as it went along, they wanted more information by teller, time of day, all general ledger codes, all kinds of stuff. Okay, which then they wanted a report as opposed to this little thing on regular paper, which I think in that selector typer, I think it was 120 characters. I think later ones had 132, but 120 characters. So the application people put together reports at in a nighttime process, and the next day to come in a branch and request his reports. Well, one of my first jobs way back in the 70s was to look for this carriage returned, okay, 0D, and a line feed. It could either have line feed, carriage return, or carriage return line feed. I looked for them two sequences in the transmission going out across the lines. And we got that. It means what it was going to do is that it was going to take the carriage that was down here somewhere. It was going to go down one line and go all the way back to the beginning of the next line to print. Okay, again, a mechanical device. It would take time for that mechanical device to go down and tick, 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 and go back. Okay, so when I found that combination of characters, I would insert idles. Idles, you might think it was no hop, but it took the same amount. It did the same thing as printing an A or a B or a C or anything else on a terminal. It took that many cycles with an idle. And I think I recall a number like 17. If I found that combination of carriage, return, line feed, I would put in 17 idles and give that carriage enough time to get back to the beginning. Because remember, I said no intelligence in this here. It was a buffer terminal, and the data just keep coming in, so you had to get it back out. So that's some history of old time stuff that I did way back in the early 70s, I guess. Anyway, enough for that. We're going to get rid of all that, and you probably want to hear that, and you can forget about it now. Right, decoding the graphic character on the screen on a Color Computer 3. All right, this comes right out of the unraveled code that's in your machine. It's the code. Capital letter A has these 8 bytes, okay? 10, 28, 44, okay? And what does that mean? How does that relate to an A? Every character you print on a screen, whether it be a decimal point, an @ sign, an A, an R, any character you print is 8 pixels high and 8 pixels across. So you got 64 pixels there. Okay, now here we've got 8 bytes. Okay, so we're going to need to figure out out of these 8 bytes, how do we get them 64 pixels turned on? So let's try to decode these things. This is taken right out of the Unravel series. You can get that Unravel series on Color Computer Archives, Documents, Books, Unravel series. You can find a Color Basic, Disk Basic, Extended, and Super Extended Basic, which is Color Computer 3. Okay, I spell Unraveled with one L. On the website, there's a little bit 2, so we're going to use 2 here. Within that code, here's where the other uppercase characters is. Okay, here's that A. Here's some same codes I showed you, 10, 28, etc., etc. A, B, C, D, and it goes on. There's all the printable characters are in these tables. Right, there was that one again. This is one we're going to try to break down. How do we make this look like that? Okay, here's a box. I got again, this is the hex 10, okay, which is here is hex 1, 0, 0, 0. Here's our 2, 8, okay, and binary, here's our 2, and here's our 8. And like we're down here, the 7C, here's our 7, and here's our C. So that's all the up and down. So what we're saying though is each one of these bytes is one line or one row. Okay, so we've got 8 of them, so we've got eight pixels down. Okay, so now we've got the 8 pixels down. Remember, each byte has 8 bits, so we've got 8 bits, and to see where our A is, I'll highlight it. Okay, here's our hex 10, 1 and our zeros. Here's our 2 and our 8, our 4, 4, 4, 4, and that's how you decode that. Okay, so again, remember these here are bits. That's what's going to go on the screen. That's just how the character is stored in memory of Color Computer 3 software. We have to decode how do you get from this to something on the screen. All right, this is a snippet of code out of my program that I will be sharing and giving to you after lesson 2 anyway. All right, so here's that same A, okay, that we just looked at, and we're going to convert it into what these characters over here. So let's bring our A back over here. All right, so we got 0001. Okay, these stuff in here that only has zeros and ones. 0 says use the background color. 1 says use the foreground color. Okay, in this example, we're getting our foreground color, but just in this is a 4, which is the yellow, and just so happens our background color is black, or which is a 0. Okay, so again, these are bits, and then we're going to move it over here. So the very first pixel says use background color, which is 00. Okay, which is there. The next one says use the background color, which is 0. It's there. Now remember, on the color computer, if you're in like H screen 2, or if you're using a 16 color scheme, it's 2 pixels per byte. So our first pixel goes in here, our second pixel goes here. So that's the first 2 pixels there. The third one pixel is also background. The fourth one now says use the foreground color. So we're going to use whatever you've told it to use the foreground color, which in this case I told it to be a 4. The 4 goes in there, and again the last ones are zeros. Okay, let's look at this one that has all this stuff in it. This line here, which has the 7C in it. The first pixel is background. 1, 2, 3, 4. The next 5 are foreground colors. So we got 1, 2, 3, 4, 5 4s, and 2 more zeros. So that's how you go from this line here to here, and now you can just print this on the screen. Okay, because we got 8 rows. There's 4 bytes, but that's also, remember, you have to double that as number of pixels. Okay, so that's our 8 pixels. There's our 64 pixels on the screen. Okay, let's jump around here. Okay, if you're in H screen 2 and you've set up your palette and you've done your H color, what you want, where your background color is black and your foreground color is yellow, like I have mine set up, and you said H print column 2 row 10 print hello world. Okay, that's being basic, and that would print down somewhere around this line here, we'll guess. So that'd be column 0, column 1, column 2 where this B is, and row 10 is about there, and it would print hello world right there. Now, in a similar language program, if you're coding and you're going to say load up the color yellow, how do we get there? Let's take a look and jump around here and say how do we get there? This is, oops, I have to put it up on your screen. I got it on my screen. This is my code, and I'm going to share this file with you too. It's a file I include. It's called colors all.inc for include. Okay, and I use it instead of have to retype all this stuff all the time. And when you include it, it's going to drop all this code out, and it will drop out this here, which you can move over to your palette and copy this into your palette. You can also uh, ignored if you use no code. It will not drop it out, but we're going to drop it out. So we're going to look at it's the colors, okay, and we're going to be looking at the fourth. We had to use no 4, which is the fourth palette register. So 0, 1, 2, 3, 4, which has a hex 36 in it, and hex 36 is underscore yellow. And to address that in my code, it's underscore underscore yellow, which says 4. And these are not in any special order. Okay, these are, but this is just I happen to type them in that way. So in mine, whenever I use this underscore underscore yellow, it's giving us the 4 that we need. Okay, so that was here underscore underscore yellow. Come up with our 4. We store that in the foreground area, an upper memory for high-res graphics, and in the includes common file. We have in there anything that begins with H dot. It stands for high resolution graphics. So H foreground color, we're going to store that color. Clear out A, load up B, our column, which same up here is column 2, and store that in H column. Load a 10 for our row and the D. And the H print itself in assembly language, you got to give it a length of your message. And this message is 11 characters long, and that would be this B here. I had it equated to that, so we got our 11 in there. Point to the message itself in this register and do a jump subroutine to this address here, which is the H print routine. That will give you in yellow on the background right here on this same as this one here, but be in the same exact place and print hello world. This code and that code's exact same thing. Okay, ignore the box right now. Here's the hello world at column 2, row 10. It's print right there. Why the box? Okay, this here's just give you a heads up, and if you're coding, say you're coding whatever you want to code, game whatever you're coding, and you design everything on paper. You got this wonderful box you draw on your paper, and you're putting a picture of something in there, and you got the player 1, player 2, you've got some scores, number of missiles left, or whatever the thing is. And you have instead of hello, it would say score 00099, okay? You draw that out on your paper and all looks good, and you start coding all this stuff up, and you draw your pretty box with your figure in there, your sprite in there, and you do all this fancy stuff, and it looks beautiful. You start coding, and you get your box in there, and you say hprint score 0099, and it prints right on the line. Oops. With hprint, you don't have any movement where you can move it, okay? It'd be nice to be able to move that over 5 pixels and up about 3 or 4 pixels, and it would print right inside that box. All it is tell you, if you're going to do something like this, anything you're going to print in basic hprint, print it first and then design your box around it. Otherwise, you'll end up recoding everything. It's just a word to the wise. Okay, let's see where we're at here. Okay, hprint is limited to 40 characters across and 24 lines up and down, just like if you're in the column width equals 40. The same thing. You can't move them. That's just it. They're just in them positions, and there is no erase, because when you're on a regular text screen and you print hello world and you want to come back and say score is 99, you say print score, and it prints it there. It replaces it. On a graphic screen, it doesn't. If you can print something else over, it just ors it right over the top of that, and it looks very bad. That's a bad thing about hprint. Okay, I need to bring up, I wrote myself a note there to demo this here. If I can... Nice name, huh? Junk 1. It was a test thing I did. Okay, there's our score 99. Row 2, column 10. Okay, and we're going to print the same amount of characters out with blanks in it. I'm going to hit the space bar, and nothing happens. Now I'm going to change the score to 100 and reprint it out. And that's what you get. There, look at that right there. That's where the problem is. It just oars right over the top. Take a quick look. What we did our H screen 2, set up our color, we printed H score, did a sub down here, wait for a key. We printed out the same amount of spaces as that was. It does nothing. It doesn't change anything because you're oring zeros over the top of that, so nothing. You print it again and you get the gobbledygook that we seen there. I think I just did one. I think I'm doing two here. Okay, here's another one. Hello World. It's not in them columns anymore. This is another basic program that did the Hello World. I'm going to hit the space bar and it's going to write Hello World backwards. Okay, again, this shows you what happens when if you don't have some mechanism to erase. That's what you end up with. And there's the 40 characters you can print. It just printed. It did for I equals 1 to 40. Print 40 X's on that row. Now we're going to do something very similar with the similar language. Hello World. If you notice that it looks like the font size is different. It's not. It's just closer together. The spacing on the font is closer together. Now we're going to hit space bar and it will do a clear erase and it will write it out backwards. And then it's going to take and print Z's as opposed to X's. It's going to print 40 Z's. Okay, the first line is on the same width spacing of which I call 8, because in between each one of these here, if you print the upper corner of one of these letters, the corner of the top of the next one, it's 8 pixels. Okay, so the spacing on this is 8. It's exactly like the X's are. I changed the spacing, which is a command, and the print routines I got for you, to 6, and it will put them together. So that's printing the same exact line, just with different spacing. Then I changed the spacing to 10. You can see it spreads them out. Then I changed the spacing to 12, and it spreads them out even more. You can spread them with what you want. It's just options that are within the code that I've been working on. Let's see what we got next here. Get back to our screen. Okay, we're back. Okay. Coding graphic characters. Okay, we've seen how we decoded that A. All right, let's code one up here. Let's do the same one. It's the same box, and we'll do a diamond. Okay, 001 and zeros, 00. So it's going to be a 3 and an 8. So this is our diamond. Here's what it is, and we're looking at the FCB. I give you an address, F0C5. What is that? That's where the percent sign is in memory. So if we take and we poke these 8 characters in there and we print a percent sign, we're going to get a diamond on the screen. Okay, so here's our hello world. I use the same way I did, take the box out, and we'll look at the code that we added. Okay, down here, line 30, this is our data. It's at what we just looked at there, 10, 30, etc., etc. That first line replaces the percent sign. I did some more of them. I just didn't just show them to you. This here line here is a box that replaces the and sign, and this one here is an arrow that replaces the quote sign. Okay, so we did for I equals 0 to 23, which gives us 24 characters we're going to do. We're going to read them and we're going to poke them in memory. Do that. We're going to poke them in. We'll do the same H screen 2, hello world, and we're going to print hello world. I put some dashes. We'll print 3 percent signs, 3 and signs, and 3 quote signs, and there's the result you would get. Okay, so now when you print out percent signs, you get these diamonds. Print that, you get these boxes and an arrow key. Dream up whatever you want as a character in BASIC, and that's all you do. If you want some special characters to use, dream them up, draw them on paper, and then poke them into memory. Let's take another excursion here and look at. Okay, this is the unraveled. Okay, I think I showed you before. Okay, and here's our percent sign at F0C5, So we're just poking into these 8 characters. The next 8 characters were the and sign, and the next was the quote sign. Put them anywhere you want. These are all special characters. You can use any one. Here's your numbers. You probably wouldn't want to put them over that. More special characters. Here's the uppercase characters. Probably wouldn't want to put them over that. And then here's the lowercase. The ones I use, I've used this in the past. Oops, went too fast. In the past, I've done this here with assembly language programs, and I've used these two here, the left and the right there. Okay, it's easy to remember, but you can use any one, as many as you want and where you want in your basic program, and print that stuff out. Okay, that's the end of this one. It's probably been a long time. We got a lot more to go in part 2. We'll cut this one off, and we'll look at some. Here's an example. We're going to use some control characters I said that we're not going to use anymore. We're going to use these characters here. We're going to, in a sense, have additional characters in them control characters. And here's our spacing command I told you about. And here it is with a 8, and here it is with a 10 and 12. So we'll get into that, what they are. And we'll do other things like how we can rotate stuff. We got some dice that we can play with, actual games. And, oops, that's it. So we'll sign off for now, and next time we won't have as much history and boring stuff. We'll actually get into a lot more stuff that we can do with the coding, and then actually show you the code is I got for share with you that you'll be able to use this stuff with. So that'd be all for now.